Hi, welcome back to this HYSYS videos. Now, in the last video, we talked about using a shortcut column, and we actually see how much of this, how much we can actually guesstimate what is the optimal design for the rigorous distillation column, so that we don't have to keep iterating, unlike for the amine absorber case, amine absorber and stripper case, because using shortcut columns for that, sometimes it just doesn't work. Because the shortcut columns usually tend to assume you want to recover like 90% of the CO2 and up, 90% of the light key, which is in that case the CO2, carbon dioxide, and sometimes you're not recovering so much in this system because of the temperature limitations. So for that reason, it would be kind of difficult to use a shortcut column for the amine system. But we can still use it for the methanol system, so not a problem. That's what we want to do. Okay, so anyway, it's at 17 stages. So the heuristic for distillation columns, it's usually at 15 to 20. So this is still a rather safe range. Okay, so question is how pure should we make this methanol? So now it's at 97%. 97.7. So according to what we see on Alibaba, people usually sell methanol for 99.9%. You can see 99.9%, and yeah, this guy's selling by the tons at 99%, 99.9%. So that we have to get this up to maybe 99.95 or above, and try to get rid of as much water as possible. Yeah, so I mean, okay, just for the exercise, let's get it up to 99.99. Okay, so there are a few ways we can do that. Either we can add another distillation column, or we can increase the reflux ratio by a lot. So let's increase the reflux ratio to 2 and see how pure this methanol gets. Okay, so apparently it doesn't do much. So, well, the other way is to get a second column. So let's get a second column. So this is going at about 110 kilopascals. Alright, so let's get another column. Alright, we should shortcut column this first. So impure, I'll just call this impure methanol. And let's clone this. Okay, what is this? Water stream cutter. Why is it unnecessary? Oh, Ping Robinson. So it should be acid gas. Transfer basis, TP flash. So this column should be using the acid gas fluid package. So let's check whether it's using that. Let's look for fluid package associations. Everything should be using acid gas. Okay, so we should be using acid gas. Oh, okay. So now this has a vapor in the inlet stream. Okay, so anyway, just now was for demonstration purposes, why we want to use a turbine to see whether how we can recover energy. But generally speaking, we don't need that. We can simply use a valve, which is much cheaper, and that won't give us the liquid in the inlet stream problem. So when you have that, usually you have to like vent out the vapor first before you send it to the pump or the turbine. So let's just do some of that. Let's use a valve instead. Control valve. And we'll do this. Alright, so the valve works pretty much perfectly. Okay. And that will give us, well, what we want. Again, a pretty pure, semi-pure stream of methanol. And let's see how much methanol is at the bottom. Very little. So mole flows, yeah. So basically all the methanol has gone up the top here. Okay, a lot of methanol. I won't say all of it. So okay, the thing is that we need to purify the water out. So probably we need to do another stream, and we will copy the conditions, the compositions and everything from this impure methanol stream. So let's go to impure methanol. Let's find impure methanol. Where is it? Impure MeOH. Just press OK. Then copy all the details. And let's hook it up to this shortcut column. Okay. So let's do a heavy key in distillate. Let's put a lower, way lower. So we have a very pure stream of so-called methanol, 99.98. This is exactly what we want. And yeah, that's HPLC grade or reagent grade. We can sell for a lot of money. Okay, so long as you find the right buyer. And what do we know? We have a 19 trace, so we can actually put it about tray 20. And the optimal feed stage is about tray 11. Condenser, reboiler, as usual, the temperatures are quite similar. So let's put another column. So we're going to have a pump here, and pressurized. We have a pressurized impure methanol. Let's say we are going in about 230. Okay. Right. So there we go. What's next? You have to put another distillation column in. MeOH, ultra pure tower. So I'm going to have this stream going in at stage 11. So we're just going to use 20 stages, and we're going to put stage 11. Ultra pure condenser duty, ultra pure reboiler duty. So wastewater 2. Okay, so do we need any venting for this case? You can see that there's hardly any nitrogen, NO, N2O, all this kind of stuff. There's very little inerts except just a little bit of CO2. So generally speaking, we don't need a vent. So we'll just have methanol out, ultra pure methanol. Okay, so we go next. HYSYS reboiler, pressure 280, pressure drop again about 85. So I'm just using some guesstimates. So 110 out, temperature 70, 130. Reflux, let's check how much reflux are we supposed to be using. So we'll put 0.55. So let's put 0.55 as our reflux ratio. And the liquid rate will be around 230 as per normal. So let's see how much methanol is there for the molar flow rates. Mole flow 224. So let's just have 220 on top, because some of it will be appearing out at the bottom. Okay, so let's go. So that converges the tower. Alright, so basically we are done with the ultra pure streams of methanol. So now we can actually send it to a storage tank. And how do we do the storage tank? You can look at this tank unit. You can put it here. Okay, and this can be going to the tank, and for this tank there needs to be a vapor and liquid outlet. So the vapor outlet will hardly have anything, so that's generally what we would term, you can term it a relief valve or something. So the relief valve are this, so we can use this relief valve. Okay, so the pressure will also be about 110 or 101.3, just 1 atmosphere. That's the relief valve. So the valve is open. So we'll just leave it as it. We'll leave it as it is. So this is a tank, storage tank. You can simulate it in HYSYS, and then this is the outlet stream of methanol. Ultra pure methanol to cell. So voila. That's basically the whole plant here, made from scratch. So this is the methanol plant, and in the next video we want to talk more about the heat integration of the distillation columns and see what else we can do. And we can talk about pinch analysis as well and tweak the system a little here and there. So thanks for watching. I'll see you guys next time. Bye bye.